Okay, good morning. So I don't know if you have checked the Google Classroom. The last video was actually technical problem, so I just uploaded on the Google Classroom, even though Gustav wrote me that it was not being able to open. I don't know.
No, the video worked.
Worked?
Yeah, it was the link to like the exercises that didn't work. Robert is agreeing.
Okay, but you told me the video is not working,
No.
and you sent me a link for trigonometric functions. I don't know even how did you get that link.
No, I found it on the Google Classroom. The video was there, but there was this other link. Maybe you were trying to like add the glee.
Okay, and one more thing is that I realized that not many of you actually did the quiz. I told the quiz is not a mandatory, but I really strongly recommend that to do it. The deadline is finished, so you need to respect that, otherwise you will be in trouble. Yes. So many part of the questions this year would be in short answers or multiple choice questions. So try to learn how to solve those kinds of problems. Yes. It's not compulsory. Even if you do not solve them, it will not affect your grades, but I strongly recommend to try to solve those. There is another quiz. I don't know, are you following what I'm writing? So there's a second one. Please do not. And unfortunately, I think I wanted not to expose the answers, but I think I will change the system of these quiz. So I don't think there is a problem if you immediately see which one you have done wrong, which one you have done right. Yes. Because there is nothing related to your grades. So if you let me, so I want to release the grades, so let me just pause this recording. Okay, now let us go back to our lesson. So officially this would be the first lesson in rational expressions, because the last video was not acceptable to upload and it was a very short lesson. So I do not want to repeat whatever we have done so far, because I told you that in this book, considering that you have studied all these things before, they are going much faster. But because this is a very important topic, I want to spend a little bit more time on this expression, on this topic, because if you do not learn this, then you will have troubles every time we want to simplify a fraction or whatever. So that is very important. Okay, so let me start by this example, assuming that you have studied this a little bit and I have recalled you some points last time. I will start with an example here. Okay, I will write simplify the following expressions. For example, if I write something like that for you, number 1, 4ax plus 8ay divided by 3bx plus 6by. Okay, let us do them one by one and continue. Okay, so if I want to simplify this expression, hopefully you remember what I told you as the important point is that when I have addition between two expressions, these expressions are bound together, so we cannot get rid of, we cannot simplify them unless we have factors. If I ask you how do you read this, you would say this is the sum of these two expressions. This is also the sum. you can simplify only factors, not these expressions. These expressions are called summands. Summands cannot be simplified, but factors, common factors from the numerator and the denominator can be cancelled out. Yes? So actually I told you that simplifying rational expressions are actually mainly an exercise in factorizing polynomials. So you need to have your skills of factorizations with you from last year. So if I want to do that, I ask myself, can I factorize the numerator? So, and then I told you that factoring a common factor out is one technique. The second technique that you usually study is the squaring pattern, and the other one is the conjugate pattern. I will teach you one more during this lesson, and this is how you can factorize a quadratic polynomial, okay, into the factors if possible. Okay, but let us just start doing that. So what can I do in the numerator? I ask myself, my goal is to simplify this. I have to factorize the numerator and the denominator in order to be able to find the common factors. So what can I do for the numerator? I can factor a 4a out. Yes, hopefully everyone agrees with me. Factoring 4a out means that in my head I have to divide this expression by 4a. What is left is x. If you want to check you have done it right, you multiply it back, you should get this answer, which is correct. And then what is left from the other one is 2y, yes? How should I check it? I multiply this back here, and here I will get the same expression, so my factoring process is correct. And I do the same process here. So what would be the answer here? I should take a 3b out, and then what is left from here is again x. What is left from here is 2y. Now, if I ask you, is the numerator a sum or a product? Definitely you will say that's a product. Product between 4a and x plus 2y as a whole. And then the denominator is also a product of 3 and b and x plus 2y as a whole. So if you ask me what are the factors of the numerator, these three, and what are the factors, these three, is there something exactly in common? The answer is yes. So this factor can be simplified from the numerator and the denominator. Here when I say it is gone, it doesn't mean it is left with 0. It means that I divide the numerator by this. I get 1, even if you don't want to write it, no problems, but you need to understand what is left is 1. And then that's 1 again. And then 4a times 1 is 4a. And then 3 times b is 3b. Of course, then this is a simplified version of this. And I told you a little bit of the domain of an expression. So this simplification is valid until that I don't have any problems with denominators. So if you choose b, x, and y in a way that the denominator vanishes, then this equality does not hold. This equality holds if it is meaningful. Yes? But if it is meaningful, instead of working this more complicated expression, I can work with this simple expression whenever it is necessary. Yes? So this is more or less a quick review of what we have done before. Any questions here? No? Okay. So let me give you more examples now. But before, let me write something and then try to ask your opinion about that. So here, number 2, I will have x to the power of 2 plus 4x plus 4 in the denominator, for example. And then I have 5x squared minus 20. Okay, can I simplify this expression?
Yes.
Okay, how should I do that? If I want to simplify this expression, I need to ask myself, can I factorize the numerator and the denominator? Because in this form, for example, don't be tempted to simplify this 4 by 20. It's not possible because 4 is a summand, not a factor. So I need to think about factorizing these expressions if possible. So for the numerator, so I will change my color to blue. Blue is the solution, yes? So here, what is your suggestion for factoring the numerator at the first, at least the first step? Yes?
5.
Factoring 5 out. So 5, and then what is left for me is x squared minus 4. And in the denominator, is there any way to factorize it? Which pattern is that, Yazor? The squaring pattern. So it becomes x plus 2 squared, yes? Of course, now I have factorized it. The numerator is in the form of a product. The denominator is also in the form of a product, x plus 2 multiplied by itself. But still, I cannot simplify anything because there are no common factors. But can I still continue? Yes?
Yes, there's a conjugate
Pattern appearing here, yes? So this becomes 5x minus 2, x plus 2. Yes, and then I will have x plus 2 to the power of 2. Okay, then what happens here? There is a common factor appearing here. So x plus 2 to the power of 2 is x plus 2 multiplied by another x plus 2. So it means x plus 2 is a factor of the denominator. And you see that the numerator is the product of 3 factors. One of them is exactly x plus 2. So this x plus 2, so I can simplify this x plus 2 here. What is left for me is 1. And I can take one of these away, yes? So what is left for me is 1 factor. I had 2 factors of x plus 2, now one of them is left. So then if I simplify that, so the numerator becomes 5, x minus 1, and the denominator is x plus 2, yes?
Plus 2.
Pardon?
About the numerator.
Ah yes, thank you. X minus 2, and then x plus 2. Of course, I don't need these pair of brackets any longer, so just let me just write it x plus 2. My preference is to multiply this back after I realize that I cannot simplify any further. Yes? Of course, if you don't do that, that's okay. But let us multiply that. So it becomes 5x minus 10. And this expression cannot be simplified any further. And that's important to understand. You are not allowed to simplify this x with that x. You are not allowed to simplify these 2 with that 10. Yes? Because they are summands, not factors. Yes? Okay. Now, let me write another example. Before that, let me ask you how, if we haven't talked systematically about factoring a quadratic expression like that. Of course, some of them you can do that. For example, a 5x squared minus 20 is a quadratic polynomial. A is 5, B is 0, and C is minus 20. So you were able to factorize it. This one is also a quadratic polynomial. A is 1, B is 4, and C is also 4. So you were able to factorize it. But in general, what happens if I want to factorize it, but this quadratic polynomial is neither of this form or that form, yes? So let us see then what happens. If you want to factorize it systematically, so assume that you solve this, you put it equal to it's 0 and find the zeros. Say that you get x1 and x2 to be the zeros of this. So I told you that you can write it as, what do you remember? We had a lesson. If I have a polynomial and I give you the zeros of that polynomial, you can write it as the product of x minus x1 times x minus x2. Do you agree? Because when you see that this is a second degree polynomial and x1 and x2 are zeros of that polynomial, if you remember one of the previous lessons, we were able to write it in this form. But of course, there is no guarantee that the number is 1, so you should have this number 1 there. Yes? Yeah?
Okay, what is that? Is that a k?
K. We don't know yet k. For example, if I tell you that, do you remember that was a lesson? Let me just ask you one question. If I tell you that, give me a polynomial of degree 3 so that the zeros are 1, 2, and 3. This shouldn't be a hard problem for you. If you remember, we discussed about that. So let me repeat my question. If I ask you, give me an example of a third degree polynomial whose zeros are 1, 2, and 3. How do you answer that systematically? Do you remember? So when, yes?
Could you do something like what you showed with k, but you put an x3 and you set it to x1 to 1 and x2?
Yes, yes. So yeah, you write one of them is x minus 1, x minus 2, x minus 3, yes? If I ask you what is the degree of this polynomial, what is your answer?
Third degree.
It is 3 because this is degree 1, degree 1, degree 1. If I multiply them, definitely it becomes a degree 3 polynomial. If I ask you what are the zeros of this polynomial, it means that you put it equal to 0 and ask yourself what are the possible values for x. But by the zero product rule, one would be 1, which you want, the other one would be 2, which you also want, and the other one would be 3, which you want. Yes? So if I ask you, give me an example of a third degree polynomial whose zeros are this, you can tell me that, okay, p of x equals to this one. This is one example. If I ask you, give me another one, what can you do? Yes?
Could just multiply
Yes,
everything
exactly.
together.
You can multiply it by 7, for example. If I ask you, do you still agree that this is a third degree polynomial? Yes? Do you still agree that the zeros are exactly those numbers? Yes. So that's also another polynomial of degree 3 with that property. Yes? Understandable or not? Okay.
Yes.
But if I ask you, can you write all of them for me? Instead of 7, what do you write? Yes? K. Because we don't know k. Whatever you like, you can choose for k. So if I ask you write all of them, if I ask you write 3 of them, you can choose whatever you like for this number. I chose 1, I chose 7. But now if I ask you write all of them, you put k. Is that clear or not? So it is all the degree 3 polynomials with that 0. So you see, if you know the roots of a polynomial of degree 3, you can factorize it easily. The point is that we don't have the roots. So if you know the roots of a polynomial, you can factorize it. Yes? For example, if I ask you, give me a second degree polynomial, no, third degree polynomial, so 2 roots are 1 and 2. How can you write that? Let us repeat that lesson. I tell you that give me a third degree polynomial, one third degree polynomial, whose 2 roots are 1 and 2. We don't know about the third root. So how should I write that? You say that x equals to 1 is a root, so it means that in the factoring polynomial, x minus 1 should appear. Because by the zero product rule, if I put it equal to 0, this gives me 1. And then the second one is x minus 2. But if I ask you about a third degree polynomial, so far what is the degree?
2.
2. So if you stop here, you haven't given me a third degree polynomial. You have given me a second degree polynomial. But if I ask you to give me a third degree polynomial, you should say that, okay, I have to multiply it by a first degree polynomial. So the general form of a first degree polynomial is of this form. Yes? And then this is a third degree polynomial whose two of the roots are 1 and 2. But the third root we don't know. It depends to our choice for A and B. So that would be the whole third degree polynomials, so that 2 roots are 1 and 2. Yes? Okay, this is just a crash review of what we learned before, but let us just be specific about this case. So if let me make it simple for you. If I ask you, let me change that because you have forgotten a little bit. So let me just write this. X squared minus 5x plus 6. Okay? I ask you to factorize this, and I give you that 2 and 3 are the zeros of this polynomial. If you don't believe, you can check them. Put 4 here, so it becomes 4 plus 6 is 10, 5 times 2 is 10, 10 minus 10 is 0. So that is indeed a 0. What about 3? Put 3 here, 3 to the power 2 plus 6 is 15, 3 here minus 15. So these are zeros. So if I ask you to factorize this, might be that would be hard for you because you haven't studied that systematically. But now if I give you that these two numbers are the roots, that shouldn't be hard for you. Can you factorize it now? Yes, what is the factorization now? You would say that because 2 is 0, 2 is a 0, x minus 2 should be in the factorization of that, yes? And you tell me that x equals to 3 is a 0, so it means that x minus 3 should also be in the factoring of that polynomial. But then you might think that there should be a number here, because still you don't know. Might be there is a number there, yes? But immediately you can realize this number k is 1. Do you know why? Why k should be 1? Yes, sir?
Because we don't have an a value.
Yes, you have an a value. The a value is 1. Yes, because you multiply this by x, it gives you x squared. If there is a k here, after being multiplied, this will give you kx squared. But on the left hand side, you have how many x squareds? 1 x squared. So it means that k should be 1. So it means that k is 1. And then you factorize this, yes? So if I give you the zeros of a second degree polynomial, it is very, very easy task to factorize it. Yes? And then I gave you the zeros, but you yourself know how to find the zeros. Yes? Because for quadratic polynomials, we have a formula. So we can use it. Okay? So for example, let me give you this. X squared minus 5x minus 6. I ask you to factorize it. So, without giving you the zeros, you don't need me to give you the zeros because you can find the zeros yourself. So what can you do? You yourself put it equal to 0 and try to solve this equation. I don't know which one you want to use. Let us use delta. So delta is b squared minus 4ac. So b squared is 25 minus 4 times this one is positive 24. It becomes 49. So the roots that I am looking for according to ABC formula is this, yes? And then minus b is 5 plus or minus the square root of 49 is 7 divided by 2 times a. And then I get my answers. One of them is 5 plus 7 divided by 2. The other one is 5 minus 7 divided by 2. So these are the roots. Yes? So what you write a k value, which you don't know yet, and then you have 2 pairs of brackets. So can you fill them up? X, what should I write here? What should I write there? Now you know the zeros.
X minus 6.
X minus 6.
X plus 1.
X plus 1, exactly. Because minus 1 is plus 1, yes? And now what is k in this case again? Yes?
1.
It should be 1 because x times x is x squared. And then kx squared, but I have 1x squared. So it is clear that k should be 1. That's it. So that's the factorization. Yes?
Is k always the a value?
I want to tell you that yes, in this case, it's always a value. Okay, that's always the a value. So what I want you to tell you that yes, you can clean this and write confidently that's always a value. And that's also clear. Why? Because if I have it in this case, x times x is what? X squared. If I have ax squared on the left, I have to adjust a, I have to put a to fix it. Otherwise this will not work. Yes? So now, yes, I think it's better now to write this. So this is the formula that you can always use to factorize a second degree polynomial. Yes? Is that clear? So for example, let me give you another one. I ask you to factorize this polynomial. 2x squared plus 5x minus 7. We want to factorize this. So what I'm supposed to do, I am supposed to find the roots myself. So you see, the problem is not an equation. This is an expression. I myself need the roots because I want to use it here and there. So this is why I changed the color. So from the blue color is the solution. So let me write this as an example properly. So example, factorize 2x squared plus 5x minus 7. Okay, then what you need to do, what I write in blue is the solution. So if I see that this is a second degree polynomial, I take that polynomial and put it equal to its 0 myself. So you see, the problem is not solving an equation. To be able to factorize the polynomial, one step is to put it equal to 0 and find the zeros. Okay, so let us use delta formula. So it's b squared minus 4ac. So this becomes 25 plus 56. Yes? b squared, 4 times this one times that one is 56, but I have two negative signs, so it becomes positive. And this becomes 81. And then the formula is minus b plus or minus the square root of delta divided by 2a. And then minus b is minus 5 plus or minus the square root of 81 is just 9 divided by 2 times a is 4. And then I have two roots, x and another x. So minus 5 plus 9 is positive 4 divided by 4 is 1. And minus 5 minus 9 is how much? Minus 14 divided by 4 is minus 7 divided by 2. Okay, and now if I want to factorize that, I would write 2x squared plus 5x minus 7 is equal to, a is 2, so I would write 2. What should I write? X minus 1, the other one, plus 7 over 2. Yes?
Yes.
This is good, but you need to do better. You see here, you have three numbers, this one and that one and that one. Okay? And this is very important, by the way. Do not write approximate values. Here you can write exact value, but don't do that. Use fractions. Of course, I can leave it like this. This is in factorized form. But in factorization, I need to tell you on which domain you have to factorize. Usually, the domain is the set of integers. So the numbers that are involved here is 2. The coefficient is 1. This one is minus 1. This one is 1. This one is 7 over 2. All these numbers are in the set of integers except one of them. If possible, you should be able to get rid of that. By default, we factorize on the set of what? Integers. So what I do, I will take these two. I could multiply it here, no problems. It becomes 2x minus 2, but still 7 over 2 will be left. But I will do it more efficiently. I will take this one and multiply it on the last one. Because I have three numbers, it doesn't matter in which order I multiply them. So I choose to multiply this one on the last expression. So this becomes x minus 1. This becomes 2x. This becomes 7. So this is what I want you to be able to write. If I ask you to factorize that, you can write this. And of course, even if you can guess, that's also okay. It's not a big deal if you want to guess. But this is a systematic way of factoring a second degree polynomial. Yes? I have some videos on my own YouTube channel that I'm talking about factorizing second degree polynomials extensively. I will put the link actually if you want to see it. If you want to see all the methods, but this is always working. of course, if the delta is negative, then there are no roots. And if there are no roots, it means that I cannot factorize it. It is not factorizable anymore. Yes? And if I have only one single root, what happens? It means that you have missed the squaring pattern. You even didn't need to use this method. Because when I have the squaring pattern, how many roots are involved? Only one. So if you solve this one and delta becomes positive, so you have two roots, and that would be the method. If delta is negative, you do not have any roots, it means that your polynomial is not factorizable anymore. And if delta is 0, you will get exactly one root. It means that, of course, if you want, you can use it. What happens? It becomes a x minus x1, but the second root is also x1. So then it means that this is a x1 to the power of 2. So it means that you can use a squaring pattern instead of this method. Yes? So that's no big deal. So, but this is always working. But this is not always the efficient way. I will also try to teach you what would be sometimes efficiently, but that needs guesswork. If the numbers are big, I cannot do it myself. I have to use the systematic way to factorize. Okay, so let me add this now. Go back to this lesson. Example, number 1, number 2. Now I want to add more examples to this one. Okay, so let me clean this. Okay, so now number 3. Let me see. Okay, let me write this for you. We want to simplify this expression. 6x squared plus x minus 15 divided by 8x squared minus 10x minus 3. Okay, so for example, let us simplify this expression as much as possible. So in this form, we cannot simplify anything because this is not factorized form. So if I want to solve this problem, this is one of those problems probably you cannot start immediately factorizing it unless you have you have improved your skills in factorizing the polynomials. But if you want to do it patiently, you realize the numerator is a quadratic pattern, is a quadratic polynomial. The denominator is also the same. So you have to do a lot of work, yes? So what you have to do, you have to put the numerator equals to 0 and try to solve the equation, yes? So let us just do it patiently. So delta, let me avoid the formula. So delta is b squared minus 4 times a times c. So minus 4 times 6 times minus 15. So then, of course, you can use your calculator. It's 1 plus 360. It is 361. And then you have the formula. X is equal to, let us avoid the formula. Minus b is minus 1 plus or minus the square root of delta divided by 2 times a, 12. You use your calculator, but I have it in my memory. This is 19. So this becomes minus 1 plus or minus 19 divided by 12. And then you get two numbers. One number is minus 1, minus 19 is minus 20 divided by 12. Definitely you have to simplify it, but exactly. So it becomes minus 5 over 3. Don't put it in your calculator. You have to work with exact values here. And the other one is what? X is equal to minus 1 plus 19, which is positive 18, divided by 12. Definitely you have to simplify. What happens? It becomes 6 over, no, sorry, we divide by 6. It becomes what? 3 over 2. Okay. And then what I do, I would write that 6x squared plus x minus 15 is equal to a value, which is 6, multiplied by x. I put two x's here and there. So what should I write here? One of them 5 over 3. One of them 3 over 2. But I told you that by default, I want to avoid fractions when I factorize. Can you tell me how should I get rid of fractions? I have two fractions involved. One is 5 over 3, the other one is 3 over 2. But the good news is that I have a 6, but 6 itself is what?
3 times 3.
So, yes, exactly. 6 itself,
Bobak,
yes?
shouldn't you take x
Yes,
minus
thank
3
you,
over 2?
thank you, thank you. You are right. It should be minus. Thank you very much. So this 6 is 2 times 3. And now what can I do? I have 4 numbers involved. I want to multiply them, but I have something in my head. I want to get rid of fractions if possible, yes? And it is possible in this case by being a little bit wise, multiplying 3 here, multiplying 2 there, yes? So I will take this 3 and multiply it only in the first bracket, and then I will take this one and multiply it here. So then, what can I write? So let me write it here. 6x squared plus x minus 15 is eventually, okay, what is that? I have taken this 2 and I have multiplied it here, so it becomes 2x. Instead of 3 over 2, I just have 3. And I have multiplied 3 here, so it becomes 3x plus 5. So you see that the problem becomes lengthy, but systematically. So you can just do it systematic. So I was able to factorize the numerator. Yes? Any questions here? Okay. Now I want to pause recording the video and I want you to do the denominator yourself. Okay, just do that because this is something that you need to learn. Okay, could you solve that? Yes?
Yes.
So good. So let me just try to do that one as well. So when this one is finished, you have to go and do the other one. So you put it 0 yourself. 8x squared. And then this is really important to use ABC formula because otherwise you have to divide by 8 and work with fractions, which is harder, I would say. So I put it equal to 0. Then I calculate delta. It's this one to power 2 minus 4 times this one times that one. It's positive 96. It becomes 196. So be careful that you are not missing minus signs or things like that. So can you confirm that? Is that right?
Yes.
Okay. And then what we have to do, x is equal to minus b, which is 10, plus or minus square root of 196.
14.
Which is 14, yes. Let me write it for the future if you need to. So you need to know what I have done. Divided by 2 times a, which is 16. But you put this in your calculator or you know it, so it becomes 14 divided by 16. Then I will get 2 answers. Then x is equal to 10 plus 24. Plus 14 is 24 divided by 16. Don't leave it like this. Simplify it as much as possible. So it becomes 3 over 2 by simplifying everything by 8. And then the other one is 10 minus 14, which is minus 4 divided by 1 over 16. And if you simplify it, it's minus 1 over 4. Yes? So what you write now is 8x squared minus 10x minus 3 is equal to a value, which is 8, x minus one of them, for example, the first one, times x minus the second one. But there is a negative sign here as well, so minus the second one turns out to be positive. Of course, it is not wrong, but I told you that we want to avoid fractions at the end. So then I need to get rid of two fractions. One of them with denominator 2, the other one with denominator 4. But the good news is that we have this exactly what we need, yes? So you don't need to write it in your head. You can just divide it as 2 times 4. Take this 2 and multiply it here. Take that 4 and multiply it there, yes? So if I do that, what is left? So it becomes, if I multiply 2 here, so it is 2x minus 3 and then 4x plus 1. Agree? So, okay. So I can write this one here, 8x squared minus 10x minus 3 is equal to that expression, 2x minus 3, 4x plus 1. Okay, then the final question mark is, the question mark becomes equal to, instead of the numerator I can use that, so it becomes 3x plus 5, and then I have 2x minus 3 divided by 2x minus 3, and then I have 4x plus 1. Yes? And then of course, is there any common factor? Yes, so this one is a common factor, so I can get rid of this by dividing. What is left for me is 1, what is left for me here is 1, and then you multiply this by that. You don't need any pairs of brackets left to write it down, because you don't need to separate it from something, and then 4x plus 1. And that is the end of the problem. I want you to appreciate that. This is the end of the problem. I cannot simplify x with that x. So it means that if I ask you, is this one always equal to that one, what would be your answer? Is this expression always equal to that expression? Yes. No? No. There are two exceptions, very minor exceptions, yes? So this equality is not working if I have these two numbers, yes? If x is 3 over 2 or minus 1 over 4, the problem is that the denominator of this one becomes 0, so it is not valid. But if x is neither 3 over 2 nor minus 1 over 4, I have infinitely many numbers left for me. For all those infinitely many numbers, this one is equal to that one. Yes? And this one is harder to work with than this simpler version. Yes? Is that clear? Okay, so and now let me give you another example that's also good to know before going to the other parts. Sometimes, this is also somehow missing probably in the Origo book we had before, but let me just tell you with an example here. Number 4, I want you to simplify this expression. So number 4, this is a little bit harder, so let me put a star here. Ax minus by, and then I will have minus ay plus by. No, this is bx. And this is by, yes. And then I want to divide it by b squared minus a squared multiplied by x minus y. I want to see if I can simplify this expression. So I have put this a star because this is not something very systematic. You need to be a little bit creative sometimes. There is a shorter way to do these things, by the way, but I don't want to go through them because that's not exactly according to our lesson. But if you want, I can put the link of a video in which that I am explaining other methods for doing this. They are short. And if you can use them in the exam, that's okay with me as well. So, but let me just tell you a little bit about this. This is a little bit different from what you have learned so far. First of all, the denominator is already in factorized form. Yes? Because this is the factor. If I ask you, is it a product? You would say yes. That's a product between these two expressions. Even though it is not fully factorized, because you can detect this conjugate pattern, but still it is factorized. It's a product. But what about the numerator? The numerator is not in factorized form, and it seems that none of the methods that we have learned so far will work for the numerator. Yes. First of all, there is nothing that I can pull out from all the expressions. Of course, x is common between these two, b is common only between these two, a is common between these two, and etc. But nothing is common in all of them. So I cannot probably use the first trick. The second trick is it's not conjugate pattern, it's not the squaring pattern, it's not the quadratic pattern. So in these cases, you need to be, this could be extremely hard, but not for these very simple cases. But I want you to learn the method. So the method is that, can I group them? You see, for example, let me take this one and this one. Can I factor something out between these two? The answer is yes. X. Can I factor something between these two?
Yes.
That y. But this is not important. The important thing is that you need to look a little bit ahead of yourself to see if after factoring each group, there is a common factor emerging again. If that is not working, you have to change your strategy of grouping them. You need to group them in a different way. So let us just try to understand that. Here, let us factor x for the time being. Then it becomes a minus b. Yes? And then here, if I factor a y out, what is left here is b. What is left here is minus a. So I failed. Yes? Because after factorizing group by group, if I ask you what are the factors involved here, you would say x and a minus b. If I say that what are the factors involved here, you would say y, b minus a. There is nothing exactly in common, but if you have your memory with you, I told you something about this situation. Yes? What was that? Whenever you have a minus b, you have b minus a, you need to think about factoring a negative sign as well. Yes? So what I do not throw this method away, but I will try to adjust myself. How? Instead of factoring positive y out, let me try to see what happens if I factor minus y out. Okay, now can you tell me what happens? If I pull minus y out, what is left from the first one?
A.
Positive a. But what would be left from the second one?
Minus b.
Minus b. Now look, is this grouping successful? Yes. Because now if I ask you what are the factors in the second term, you say y and a minus b, and the point is that a minus b is a new common factor. Okay? And then what you can do, you can take this one and pull it out. So what happens? A minus b is pulled out. This is pulled out. What is left? X. From here, this is pulled out. What is left? Minus y. So that's the factorized form of that expression. Okay, I want you to see that, but I will not, of course, emphasize on these type of exercises a lot because I haven't seen exercises like that in the book, but it is not very hard for you to understand it. So if you don't believe, you can multiply this back. A times x, ax, a times negative y, negative ay, minus b times x is negative bx, and finally minus b times minus y is positive by. So what we have done is completely right. So these kinds of factorizations are not that systematic. So it means that you need to look a little bit ahead of yourself, and this will come by a lot of practice, so that you can group them and factor each one of them in its own group, to hope that a common factor between groups will emerge. If it doesn't work, it means that your grouping was not correct. You need to change the grouping. And if it doesn't work, you need to invoke another way of doing that. Yes? Any questions? Okay, now we go back to the problem and try to solve that. Okay, so let me see if you remember what to do now. So the denominator is already in partially factorized form. It is not fully factorized. But let me write it here. So I will go back to my question. So the question mark is equal to, instead of the numerator, I can just write a minus b, x minus y. Okay. X minus y is good, by the way, because it will be cancelled. But what about b squared minus a squared? Yes?
Conjugate.
Conjugate. Okay. So if I do it, it becomes b minus a, b plus a. Everyone agrees? So I have 2 factors in the numerator, 3 factors in the denominator. How many common factors you see in this form? How many factors you see? What? Yes?
X minus y and x minus y.
Yes, only 1 factor. So, but they are very similar, even though they are not identical. But the same trick again. We have to use the same trick again. So what can I do? I can simplify this one with that one, no problems. So what is left in the numerator is a minus b. What is left in the denominator is b minus a multiplied by b plus a. Of course, you manage to simplify it. This one is much easier to work with respect to this one. But still, we can simplify it more, but not exactly right now, because this is a minus b, this is b minus a. They are not the same. But I can use the same trick. What was the trick? For example, I can factor a negative sign out. I told you that whenever you have a minus b and you want the other way around, write it in this form. Yes? And now you see that this factor and that factor are in common, so I can simplify that. What is left from here is 1. What is left from here is 1. But there is also a negative sign left, which becomes minus 1 divided by b plus a. So, and I hope that you agree that this long expression is all equal to that one, of course, when x is not equal to y and b is not equal to a, because on that case, the denominator would be 0. If x is not equal to y and b squared is not equal to a squared, then the whole expression here is exactly simplified in that form, and working with this is much simpler. Yes? Is that clear? Okay, so let me see if I can find some of these type of examples for you so that you can work on it. Okay, so on exercise number 5 and 6, the emphasis is actually on this type of factoring, both for the numerator and for the denominator. These are actually very simple. You really will be able to do it, I'm sure. So try to do them, and we come back and solve it together. And I will solve one of them for you because I want to finalize this. So I will give you 4 minutes, and then it takes me a little bit time to solve it for you. And one of them will be left as an exercise. We can complete next time. Okay, could you solve the first one?
Yeah.
Okay, so it's simple, you see, it was not that hard. So what I do, for example, let me just write them separately. I don't know, how did you group them? One possible probably way is to group these two together and these two together. Okay, one other possibility is to take this one with that one and this one with that one. Both of them will work. Yes? For example, let us take this one with that one. My goal is to factor y out, but that is not that important. The point is to look a little bit ahead of yourself. I have to factor y out. What will come out? X plus 2 will come out. And when I factor a 3 out, x plus 2 will come out again. So that is the important thing. Yes? The important thing is to be able to look ahead so that the common factor will emerge. So this grouping will be successful. So I will factor a y here. It becomes x plus 2. And then I factor a 3 here. It becomes x plus 2. Is it successful? Yes, because now I see the common factor emerges. So I can pull it out. And what is left from the first expression? Only y. And what is left from here is plus 3. So that's completely true. Yes? I don't know. Let me just write with a different color. So might be you take this one with that one and this one with that one. Let us see if it works or not. If I take this one with this one, how should I factor out? I can factor x out this time between these two. What is left is y. What is left is positive 3. If I factor a 2 out between these two, it becomes y. It becomes 3. Is it also successful? Yes, because again, y plus 3 emerges. And if I factor y plus 3 out, then from this one, x is left. From this one, positive 2 is left. But there is no difference between this one and that one. They are quite the same. So here we had two grouping alternatives. Yes, that was working. But one of them is enough. And if I go to the denominator, so let us solve it only in one way. So which one do you prefer here? I think this one with this one will work, and this one with that one. Why? Because if I pull y out, x plus 2 is left, and if I pull 4 out, it becomes x plus 2 left. And that is good, because now I have my common factor that I need, so it becomes y plus 4. Yes? After this is done, I go and write my question mark is equal to, the numerator is that expression, y plus 3, and the denominator is x plus 2, y plus 4. And then this common factor is cancelled, so it becomes y plus 3, y plus 4. Yes? Am I right? How many of you got this answer? Yes, good. And this is something interesting, you see. There is nothing related to x here at the answer. So it means that if the denominator here is not 0, this expression doesn't care about the x value at all, because x value doesn't play any role at the end. Yes? Whatever x dependence is here, it's cancelled out. Yes? So if the denominator is not 0, it doesn't matter which value for x you choose. It's always related to y. The y value matters, but the x value doesn't matter. Yes, because you see at the end, it is related to y value. Yes, do you agree with me? Yes. This one and that one are cancelled. So the x dependence is cancelled out here. What is left is y dependence. So as soon as x is not equal to minus 2, where this one becomes 0, if x is a number that is not minus 2, then this expression doesn't relate itself to x value at all. It doesn't matter. The x value doesn't matter at all. Yes? Yes?
Is it only minus 2 or is it also minus 4?
Yes, minus 4 for y.
Okay, yeah.
But for x, you shouldn't be minus 2. Yes. Yes. And then this will be left. That's also something very easy. I think you can solve this one yourself. So let us just stop the lesson here. But please do these exercises and try to do the quizzes. They are actually important. Okay, thank you very much.
Thank you.